All right, so we want to do calculations that I will call mass and moles calculations. So what are these calculations? We are going to solve several examples. The first example is what is the mass of 2.35 mole of NaCl. So we want to find mass from moles. So to solve this, first find the molar mass of sodium chloride. So this one will be given by the mass of sodium plus the mass of chlorine, which is 22.99 grams plus 35.45 grams. So this one gives us 58.44 grams per mole, because it is mass of 1 mole of sodium chloride. So the question is, what is the mass of 2.35 mole of sodium chloride? So for this question, this one is a conversion factor on its own. It is telling us that 1 mole has 58.44 grams. So that is our conversion factor. Now, what is our given quantity? This is the given quantity. So we start with the given quantity, 2.35 mole times. So because we have mole here, we need to have mole down here, which means we are going to have grams down here, up here. So mole goes with 1. Grams go with 58.44. So when you multiply this, you get 137.33 grams. Now this one is given to 3 significant figures, which means our answer also must have 3 significant figures. So the final answer is 137 grams to 3 significant figures. Now let's go to our next problem. What is the mass? What is the mass of 3.33 mole of C6H12O6? Now also the first thing is you need to find the molar mass. So the molar mass of C6H12O6 is 6 times the mass of carbon, which is 12.01 gram, plus 12 times the mass of hydrogen, which is 1.008 gram, plus 6 times the mass of oxygen, which is 1600 gram. So our answer is 180.16 grams, but this is per mole. As with the previous problem, this value here tells us that 1 mole is equal to 180.16 grams. So that's a conversion factor. But in this case, this is our given factor. So we are going to have 3.33 mole times, we need to have mole down here and gram up there. So 1 mole, 180.16 gram. So when you do the math to 3 significant figures, you are going to get 600 point gram. That tells you that we are including the zeros in the significant figures. So that's how we get mass when given moles. Now, how can we get moles when given mass? So getting moles when given mass. Example: what is the number of moles in 28.0 gram of C3H8? So the first thing, as usual, we need to find the molar mass. So the molar mass, sometimes it will be given C3H8 is 3 times 12.01 gram and 8 times 1.008 gram, which gives us 44.09 gram, but it is for 1 mole, so grams per mole. Now here the same, this part is telling us that 1 mole is equal to 4.09 grams. So what is our given quantity? The mass here is our given quantity. That's what we start with. So we start with 28.0 gram times, down here we need to put gram, up there we need to put mole. So for gram, the gram goes with 44.09, the mole goes with 1. So when you do the math, you find that the answer is 0.635 mole. Here gram will cancel with gram and will just remain with mole. So this is our answer, and the answer is given to 3 significant figures, because our question here has three significant figures. So let's solve a similar problem. What is the number of moles in 2.53 gram of sodium hydroxide? So for this one, we also need to determine the molar mass. So the molar mass of sodium hydroxide is given by mass of sodium plus mass of oxygen plus mass of hydrogen, which is 22.99. So these masses, you get them from the periodic table. 16.00 grams, 1.008 grams, which is 40.00 gram. Now here you are given quantity. This is 40.00 gram per mole. So this one also tells us that 1 mole is 40.00 gram. Now, this one is our given quantity. So we have our given quantity 2.53 grams times the conversion factor. This is grams here. We need grams down here, which means we have more up there. So the grams go with 40.00, the more goes with 1. So for this one, the answer is 0.0633 mole. So this one is given to 3 significant figures because the question here also has 3 significant figures. So those are the problems that we can solve, from moles to mass, from mass to moles. Now let's go to our last set of problems for this part. So here we are solving between moles, mass, and number of particles or number of molecules. So particles means molecules, atoms, or formula units. So that's what particles mean. So let's see an example. What is the number? What is the number of C3H8 molecules in 25.2 grams C3H8? So solution, the first thing you need that molar mass. Sometime you'll be given, or then you have to calculate it. So molar mass of C3H8, we already calculated it, is 44.09 gram per mole. So conversion factor 1, this is a conversion factor that tells us that 1 mole is 44.09 gram. We also have another conversion factor. Normally when you are moving from mass, here you are given mass, you need to get to the number of particles. You also need to know that 1 mole is equal to 6.02 times 10 to the power 23 molecules. So we have two conversion factors that we can use here. As usual, we start with the given factor, 25.2 grams. So I'm gonna start here, 25.2 grams times, I need to take care of the grams, so there's grams here, I will put grams down here. As you can see, in A, this is B, in A the grams go with moles, and then I'll have another conversion factor down here. Because there is more up here, I will put more down here. This one is from B. This one goes with molecules. So I just put the values in there. The gram has 44.09. The mole has 1. And this mole has 1. And the molecules has 6.02 times 10 to the power 23. So when we make our calculation, the answer is 3.44 times 10 to the power 23 molecules. So the answer will have 3 significant figures, because our question here also has 3 significant figures. Let's look at the second problem. Uh-oh. Disconnect layers. So the second problem, what is the number of formula units in 0.25 gram of sodium hydroxide? So for this one, we are moving from mass to the number of formula units. So what we are saying, we have mass. From mass, we need to find the moles. From the moles, we need to find number of formula units. So really, it's just a matter of dealing with conversion factors. Each point must have its conversion factor. So we say for this one, the first conversion factor is the molar mass. And the second conversion factor is compares 1 mole to the number of formula units. So what do we do? Let me get rid of this one first. So here we know that the molar mass of sodium hydroxide is 40.00 grams per mole. So that is a conversion. 1 mole is 40.00 grams. But also, because we are getting the number of particles, we also know that 1 mole is 6.02 times 10 to the power 23. So that's our two conversion factors. So we are given the mass here. That's what we put at the beginning. So at the beginning, we are going to put our given quantity, which is 0.25 grams. So from grams, we have grams up here. We need to have grams down here, and then more here. And then we have more there. We need to have moles here, and then units here, formula units. So we just need to put our conversions there. Gram goes with 40.00. The mole goes with 1. Here, mole goes with 1. Units. So this is units. Units goes with 6.02 times 10 to the power 23. So for this one, our answer is 3.8 times 10 to the power 23 formula units. So it is to two significant figures, because our question here also has two significant figures. Now, sometimes you may be given number of molecules to get to mass. So this is one of the problems. So number of molecules to mass. So what is the mass of 7.25 times 10 to the power 24 molecules of C6H12O6? So for this one, as usual, you need to determine the molar mass of C6H12O6, and we already calculated this one, 16 grams per mole. That's the first conversion. So the first conversion is 1 mole is 180.16 grams. The second conversion is 1 mole is 6.02 times 10 to the power 23 molecules. So this is our given quantity. That's what we start with. 7.25 times 10 to the power 25 molecules times, so we must have molecules down here and more up there, then times we must have more here and grams there. So we have used the two conversion factors, A and B. So molecules go with 6.02 times 10 to the power 23. Here it goes with 1. Here it goes with 1. Up here it goes with 180.16 grams. When you do the math, make sure that you are putting these ones in parentheses so that you don't mess up the calculation. So when you do the math for this one, the answer is 2170 grams. So I'm saying 7.25 times 10 to the power 24 molecules of C6H12O6 contain 2170 grams. So let's do the last one. What is the mass of 2.9 times 10 to the power 23 sodium chloride? So our solution, the first thing we need to get the molar mass. The molar mass of sodium chloride is 58.44 grams per mole. So this tells us that our conversion factor is 1 mole is equal to 58.44 grams, and also 1 mole, because we are finding the mass from number of particles, 1 mole is equal to 6.02 times 10 to the power 23 of the sodium formula units. Now, this one is our given quantity. That's what we start with. So we are going to have 2.9 times 10, 23 units times down here we're having units, and here more. Then down here we have more, and here, and then we have grams. So everything needs to cancel. So for units, down here we have 6.02 times 10 to the power 23, 1 more, and here we have 1 more down here, and 58.44 grams. So when you do the math, and the answer will be to two significant figures, it is 28 grams. So that's how we solve these problems.